morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Design News webinar, Time to Rethink Enclosures, How Thin Films Are Transforming Product Design, sponsored by HCO and broadcast by Informa. I'm Michael Krieger, and I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speaker, share this webinar via social media outlets, and participate in the Q&A session that will take place at the end of our presentation. The slides will advance automatically throughout the event, and toward the end of our webinar, we will ask you to complete our survey found on the right-hand side of your screen. Take a minute to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events for you. Lastly, if you're experiencing any technical problems, please click the Help widget found at the bottom of your screen or type your issue into the Q&A area, and we'll be glad to offer one-on-one assistance. Now, on to the presentation, Time to Rethink Enclosures, How Thin Films Are Transforming Product Design. Discussing today's topic is Zsolt Pulai, Executive Vice President for Technology at HCO. Now, Zsolt, over to you.
Thank you, Michael, and welcome everyone. My name is Zsolt Pulai, and I'm the Executive Vice President of Technology and Research here at HCO. I've been in this high-tech coating industry for almost 2 decades, starting my career in thin film solar manufacturing processes. And I've been involved with HCO since the late 2012. So today we will discuss how we can produce products that are more reliable and lower total cost of ownership while at the same time we simplify the design. So this is a new way to think about protective enclosures to safeguard our critical electronics from all of these environmental hazards. So enclosures have historically been used for protection, and we are all familiar with them, but they have not necessarily stood up to the test of the time. So additionally, changes in technology now prompts calls for us to change the way how we think about protecting these critical electronics. So let's discuss these changes. So there are trends in technology today, I am sure that you are aware of, that make the product design much more complicated than it used to be. So devices are becoming more capable and more complex. For example, more functionality. Following the trajectory of Moore's law, we all know that transistor count doubles roughly every 2 years. So more capabilities lead to more responsibilities. So as they become more capable of fulfilling some of these complex tasks, they are increasingly being used to manage the critical infrastructures. So more responsibility calls for more reliability, of course, at the same time. So as these devices become more functional, processing facilities are being built where resources are located, otherwise we know it as edge computing. This is true for mission-critical applications like industrial, IoT, and automotive. The reliable operation of these devices is a mandate, it's a must. So this leads to more environmental protection demands. We need to make sure that we protect what is important and what is critical for us. So edge computing environments include deep water or most remote deserts, and then some of these very hostile environments. So exposures to corrosive chemicals such as salt or sulfur or chlorine, and then high temperatures or temperature extremes, oil, and any kind of other contaminants are a huge threat for reliability. And then this is just to name a few of these environmental hazards. So by the way, this gives the enclosures a run for their money, since we all know that even the 316 stainless steel can corrode in such of these environments. So more protection demands and functionality are concurrent with miniaturization. So we have to make sure that these boards get smaller and smaller, and then we need to reduce cost. A small device cannot have a huge enclosure around them. Smaller devices, transistors are there, and then they are getting smaller and smaller, just like Moore's law predicted that this milestone will be reached by 2020 last year. And then cost reduction is important in our case as well, cost and size, because prices have dropped dramatically in almost every tech sector thanks to Moore's law. And all of these factors cause new needs. Some of these needs are conflicting, and it's up to you as design engineers and stakeholders to so-called walk the technology tightrope. So what would it mean to you if many or all of these issues were resolved with little or no compromises at all? What if you could satisfy increasing protection demands without adding bulk or interfering with functionality? Or if there was a way or an easy way to reduce these costs, what you have budgeted for these products? What if all you have to do was approach the problem differently?
And with that, let's put our attendees to work with our first polling question of the day. What is your biggest design challenge? Is it the cost restrictions? Is it sustainability or environmental concerns? Is it miniaturization of bulk and weight? Or is it reliability? And please take a moment to respond to the poll. And Zolt, while we're waiting for the attendees to respond, let me ask you a question. Has there been any impacts to the coating industry as a result of the current pandemic?
I would say the current pandemic affected almost everything, so the coating industry as well. Not just the coating industry in general, but the demand from consumers potentially affected it. So the answer is yes, but luckily, just like everything else, this is also recovering very fast.
Terrific. Okay, let's see what our attendees have had to say about their biggest design challenge. Let's take a look at the results. Number one, about 40% of our attendees are saying is cost, followed by miniaturization, reliability, and sustainability. Any surprises there for you?
Actually, this is exactly what I expected, and I'm glad that the attendees read my mind because our presentation will be around points. So thank you for the answer.
I'll turn it back over. Yeah.
Excellent. Thank you. So are the enclosures a problem or not? So I'm sure that most of you likely utilized or are looking to utilize some of these enclosures, and then you realize that there are challenges with these enclosures. So enclosures can keep the dust out, keep the lint and other falling particles out, but like everything else, the enclosure has its limitations as well. So are the enclosures part of the problem? So protective enclosures are often viewed as a necessary evil. They have one major job. They need to protect the components from the environment, and this can include, of course, exposure to chemicals or moisture or heat. So off-the-shelf enclosures don't typically offer the necessary protection we need because they require customization. If it's an off-the-shelf enclosure, it does not necessarily fulfill the purpose. Customization is important. Once we do the customization potentially can mean higher cost. Of course, it has to be simple enough because it has to fit into a footprint, or we have to consider thermal loading, or we have to consider a lot of other aspects like the size or the dimensions or anything else. So after we figured all of these out, we need to make sure that we have a budget to work around, right? We don't have unlimited budgets here, and because of these constraints, we have to make sure we fit within the certain budget so that the cost itself. And of course, at the same time, there are potential failures and potential risks associated with these enclosures as well. And the most important thing is what I believe, that over time, these enclosures can break down earlier than the end of the product life cycle itself. So the enclosure can potentially fail earlier or sooner than the board we are trying to protect. So all of these things incredibly complex and complicated, and it's labor intensive, but at the same time, potentially that's not the case, and then we can show you why. So in this webinar, you will see that we can open up some new possibilities for you that you might not have considered before. In this webinar, we can talk about exploring some solutions with these enclosures. We can discover how nanocoatings can impact the design when you try to select the enclosure itself, or you try to select some different way of considering the protection for the electronics. We will also discover the ins and outs of meeting the NEMA and the IP requirements with these nanocoatings, which is an important factor when we consider the protection itself. And we will learn how to engineer cost out of the product, while at the same time we can eliminate the bulkiness and then the heaviness of the protection itself. And then, of course, at the same time, we can find out how to improve the product performance and protection with some alternative ways, namely the thin film solution. So we need to think outside of the box. So new demands call for new ways of thinking. While good protection like enclosures, they seem obvious, Great protection is transparent. And what do I mean by transparent? It's literally a transparent thin film coating, which I will talk about shortly. So are enclosures a fail-safe method? The answer is no. Just if you look at the picture here on the left side, you can see that this is an electronic circuitry inside of an enclosure which is severely corroded. And then moisture can still pass through the plastic box or the rubber gasket as well. So some of these enclosures, of course, they have the rubber gaskets, and they are sealed by the rubber gasket. But this gasket can go wrong. They can wear out, or potentially over time, they can completely even disappear. And then the problem with the gasket is moisture. Moisture can get trapped inside of the box. So the box is not breathable. It cannot breathe. And then this trapped moisture cannot escape and will condense to become sitting water inside of this box at night or during some colder weather. So, of course, we can imagine that if there is a water trapped inside this box, that can cause problems, more problems than we can expect from the protection itself. So, unlike enclosures, nanocoatings protect from the inside out. They provide the extra protection. We can use a very, very thin film, a very thin layer, which is, again, as I said earlier, literally a transparent thin film, transparent film on the board itself. You can see two boards here, one on the left, which is heavily corroded without protection, or you can see the same board when we apply a very thin layer, a very thin film on that board. In that case, it's a paralleling coating. And then you can see that that board is not corroded because the protection itself on the board. And there are some characteristics we need to consider. For example, water vapor transmission rate, how these thin films can breathe, and there are many other benefits we can consider when we think about the protection itself instead of the enclosures. So nanocoatings can, in some instances, eliminate the need for these enclosures, or they can be used as a belt and suspenders approach. So they can provide a truly fail-safe electronics protection. So this can certainly simplify the design, and then the simplified design can make our jobs easier. So customizing these enclosures to protect from the environment is a complicated and expensive process. I mentioned this earlier that there is no such thing as off-the-shelf enclosure available for the board itself. So we need to make sure that we design any kind of protection into our product. So when we use enclosures, we have a lot of design challenges. So for example, miniaturization, right? The PCBs, they have to be small enough, and this is a design constraint. The board has to be smaller and smaller, and the boards have to be smaller to accommodate these enclosures. The enclosure itself also has to be small enough that it has to fit in the envelope provided by the customer. And conforming to the size and shape and space is very difficult. This takes a significant amount of labor, and then this labor can add to the expenses. And there is a critical role of industrial design in product development. It has to look good, so the aesthetics have to be there. It has to function, so the functional point of view is an important thing as well. And today, customers are demanding more ergonomics and more functional designs. And all of these can pose some challenges on the product design itself. For example, the left thing here is lightweight. This potentially, in order to protect an electronics, the weight of the enclosure or the weight of the coating can play into the designer's job. So unlike customizing these enclosures, thin film coatings and nano coatings seamlessly integrate into your manufacturing process of the PC boards. What do I mean by that? We can have a factory-in-factory concept where you have your PC boards being manufactured, and we can be part of that factory-in-factory concept. So we can be one of the steps in the manufacturing process. Actually, this step is to protect the electronics without the need of adding these enclosures. And then these thin films are ultra thin, so they seamlessly integrate into the design. No need to increase the size of the board by having these traditional protections around them. Some of you are, or most of you are familiar with, for example, dip coating a PC board. If you dip coat the PC board, you put it into some kind of silicone, or you fill up the box with some kind of silicone. Yes, that can get the job done, but at the same time, it's very heavy, it's very bulky. These thin films are ultra thin, as I mentioned earlier, and they can seamlessly integrate into the design. So this simplifies the job, and it saves you a lot of headache and a lot of cost. We can drive these costs down. So let's look at some other ways how protective coatings can help simplify this process itself.
And for that, we will put our attendees to work one more time with our second polling question of the day. What's the biggest threat to your product's reliability? Is it environmental issues like rain and moisture? Is it temperature extremes? Is it chemicals or solvents? Or is it overheating? And again, while you take time to complete the poll, also remember you could submit your questions to Zolt at any time. We will get to as many of those questions as we can during the Q&A at the end of the event. Zolt, I imagine with the explosion in IoT devices that we've seen in the past few years, redundant protection must be a critical element that a lot of these manufacturers are looking at.
Exactly. Not only that, but nowadays the consumers like you and me, we expect if we pay for something, we expect that something is already protected and well protected. In the past, I believe consumers were willing to pay some extra for protection, but today it's necessary and today it's expected. So this becomes more and more critical that the protection is there.
And that result shows in the poll results where just over half of our attendees say it is, in fact, environmental issues like rain and moisture that are their number one threat to reliability. Any surprises on this one?
Again, everybody can read my mind, so definitely these are the two main things, environment and then overheating. At the same time, I believe chemicals and solvents are important as well, but of course it depends on what kind of industry you end up using those products. But definitely the environment is an important one, and then overheating. One is keeping the water out. The other is the heat we need to get rid of. Enclosures sometimes, unfortunately, play against these two things. So thank you for the answers, and then let's see where we go from here. So once again, there is an agency called the National Electrical Manufacturer Association, or NEMA. And they have ratings and standards, and these ratings are useful in defining the type of environment in which the electrical enclosures can be used. This is just a quick summary. We try to summarize here what I mean by that. So the NEMA rating system is definitely defined by them and frequently signifies the fixed enclosure's ability to withstand certain environmental conditions. For example, I mentioned like 6 or 8 of them here on the left side. So this table signifies some of these specific type of designations by NEMA. And these NEMA ratings have more testing requirements to verify the protection for example, ice or corrosive materials or oil or dust or water. So there's a very expensive or time-consuming tests they need to be done in order for us to show that indeed these elements cannot damage the board or damage the critical PC board or critical devices we try to protect. And thin film coatings, we believe, can help to meet many of these NEMA requirements. Some protections can meet certain requirements only, but thin film coatings could make many, if not all, of these requirements at the same time. And there is another interesting word here, which I'm sure most of you are familiar with. This is called the IP requirements. We also need to make sure that the thin films, they meet these requirements. For example, liquid ingress protection ratings or the IP ratings, these are standards that your customers may want you to meet, and that is define how much ingress your device can withstand. For example, there is the IP level 0 to 8 today, and I'm sure that most of you are familiar with these ratings, IP or IPX ratings. And enclosure standards, like there's an IEC standard, they also define ventilation requirements. And ventilation is important. Some of you mentioned in the previous survey that heat is a problem. If the enclosure is not correctly ventilated, then condensation can build up. And this condensation inside the enclosure could potentially be an explosive atmosphere as well. So the ventilation is an important factor to consider, and this is also part of some of the IP ratings to protect against things coming into the box or the heat going out of the box. And additionally, to meet some of these IP standards, we need various seals, and it's an important problem because these seals can potentially make the product bigger, and nowadays we all know that all the products, all the electronics are getting smaller and smaller. It does not look professional to have a tiny little device, but a very bulky, very heavy box or very heavy silicone around the board itself. And thin films can protect from the inside out, and no outside protection is needed. I know it's a little bit strange to say that no protection is needed from the outside, but I do believe that if the PC board or if the device is correctly protected, that very thin layer, very thin film can do the job, can get the job done. So far we have discussed how these protective coatings can make the job easier, how they can reduce the cost, the bulkiness, and the weight, and how they provide the reliability we need. So in addition to this, thin film materials can be used for many, many other benefits, many, many other properties. And this is what I like to spend some time on explaining these one more time, or spending some time actually saying how we can reduce the cost, how we can reduce the bulkiness, and at the same time how we can get the weight lighter and lighter, which again, based on what I said earlier, is an important requirement. So let's see how we can reduce the cost. So the cost is not only the enclosure itself. So when we say that the enclosure costs whatever X, that's true, but at the same time there are many hidden costs associated with these enclosures. For example, the extra labor or the extra material resources, all of these can increase the total cost of ownership when new equipment or upgrades are added over time. And then these changes may bring some other problems. For example, as I said earlier, the NEMA ratings or NEMA requirements. So the manufacturing line conversions, if there is a change with your product, then you need to convert your manufacturing line. All of these can add more cost. And then at the same time, thin film coatings are cheaper than making a casing for each part. So the per unit cost is an important factor. So the per unit cost can be substantially cheaper than an enclosure itself. And after the design, you need testing, sending off to a lab. All of these testing can cost money. All of these can add substantially to the cost itself. And of course, these testing have to be verified by a testing engineer, and then that testing engineer's job is to inspect all of these items immediately after the test is completed. So that adds another cost, and so on and so on. I'm sure I can continue adding to this list. At the same time, as I mentioned earlier, we can reduce the bulk. We can reduce the bulkiness. So you can imagine that there are enclosures, standard enclosures, 16 inches by 12 inches by 6, or up to 72 by 30 by 20. All of these standard enclosures are there. They potentially not fit your product, but potentially there is extra room inside of the enclosure itself. And then this unnecessarily thick piece of metal can also add to the weight, to the bulkiness. And this reducing the bulk is critical to meet the reliability demands. And then, as I said earlier, everything is getting smaller and smaller and smaller. So nano coatings can help to meet these demands by completely eliminating the need for these bulky seals and gaskets and sub-enclosures, or in some instances, the enclosure itself completely. And I mentioned earlier the weight as well. So enclosures can weigh anywhere between, 10, 20 pounds to several hundreds of pounds, depending, of course, on the size of the board we are trying to protect. So whether it's lightweighting an electrical vehicle, designing for sensors on an IoT or industrial equipment, keeping weight in check matters for design engineers. They want to make sure that it's not heavy, it's not bulky, so we make their job actually harder by giving them more challenges. So nano coatings are a great help to design and development companies because they seamlessly blend into the product itself. They meet the ergonomic and aesthetic requirements as well. So nano coatings are very lightweight. They are less bulky. They are proven, meaning you don't have to send them for testing. So we will go into some details about meeting the standards in the next slides, so you will see. We don't have to worry about converting to other NEMA ratings or adding protection. And also with these enclosures, higher IP and NEMA ratings for enclosure usually means higher cost, longer design time, higher manufacturing cost, and so on. So let's look at how these nano coatings can help to meet and exceed these standards and requirements. So we'll be specifically talking about our process here at 8Zero. And some of you potentially have other service providers or solution providers, so you should speak to them about the exact properties that the coating they provide for you can have, and if these coatings will meet these standards or not. So there are some physical properties, of course, as I mentioned earlier, the weight and then the mass, how lightweight the protection material can be, or performance is very important. I believe in the survey we also talked about the importance of the performance. It's not good to have a very fancy enclosure, but at the same time, it's expensive but does not protect against what we need. And again, there's no such thing as off-the-shelf enclosure can get the job done. And then at the same time, value is more and more important because, of course, the protective coating must provide the expected value from the cost and performance point of view as well. Otherwise, why do we do the protection itself? So based on this, we believe that this was also part of the survey results, the heat dissipation. So one of the ironies with enclosures is that we work very, very hard to get everything enclosed to protect it, but then we find ourselves stuck with the problem of being closed up too tightly. Most enclosures today need some form of cooling. We need to get rid of the heat to have a reliable operation. So the necessity for sealed enclosures is definitely there, but at the same time, this necessity can work against us. So this heat, if it's not dissipated correctly, can lead to some premature failure of these electronics. And in fact, that just a tiny little bit of increase in temperature, 8 to 10 Celsius, over the maximum rated temperature shortens the service life of the semiconductor by roughly half. This is an important point to consider. If it's warmer than it should be, and not much warmer, but as I said earlier, only like 8 to 10 Celsius warmer, the semiconductor life can be as little as half. So sometimes we need to service the electronics. We need to connect something or put an SD card in it. So we need to open up this enclosure. So each time we open up this enclosure, we change the atmosphere inside. So this also can potentially play against us. So if we are talking about this belt and suspenders approach, what I mentioned earlier, then we better investigate some thin film coatings. Thin film coatings can get many, many advantages what we desire for our product. So our coatings can enhance heat dissipation when compared to these thicker coatings with higher thermal conductivities. Or because of our coatings are much lighter, much thinner, they provide a better heat dissipation compared to other coatings, and of course, assuming all else is equal. So because it's a very, very thin layer, it's a very, very light layer, the heat dissipation is much, much better. Of course, it's important to talk about how we can improve the performance and how we can refine some of these electrical properties. I believe this is a little bit of a technical slide, but I can just briefly mention this, and of course, during the questions or during the follow-up, we can definitely address more questions or concerns about these technical numbers here. But just to mention a few, the dielectric strength is a measurement of the insulation itself, the insulation strength. So for protective coatings, the higher the number, the better. The hydrophobicity, the greater the hydrophobicity of our coating, the better. This helps prevent water to go inside and potentially negatively affect the dielectric strength. And again, the dielectric constant is a measurement of response to an electric field. The electric constant higher than 3.0 means that molecular response to an alternating field and current is different. For protective coating, this may affect the circuit speed itself. So depending on what we apply on the board, actually the circuit speed can slow down, which again works against us. So the lower the number, the better for high-frequency devices. There is an expression called the dissipation factor, which is an important measurement of the electrical properties. Thin film coatings have great electrical properties, and again, we can go into technical details on that one if any of you is interested in that one, or we can certainly follow up what we mean by that. But I can give an example. The protection, the insulating layer has to be a pure, pinhole-free, very sturdy layer to get the necessary protection, get it done. So how can we improve performance? How can we check the chemical resistance properties? So chemicals can eat through the enclosure material. I mentioned earlier, even the 316 stainless steel can potentially corrode depending on what kind of chemicals we use. And here we list a few chemicals that you can see that some of them are unsatisfactory, limited, moderate, but you can see that thin film coatings, all of them are green. All of them are green, meaning that they are satisfactory against, just to mention a few, chlorine, hydrogen sulfide, sulfuric acid, just to again mention a few of these chemicals. And our Sentinel series nano coatings can survive exposure to even isopropyl alcohol immersion. So this is a chemical resistance test method or test way. And perylene has an excellent chemical resistance. Perylene is one of our materials we use to protect the board, and I believe I have another slide on that one as well shortly to explain. And these thin film coatings are not affected by most of the chemicals out of there. Both our Sentinel and Guardian protections have passed the so-called mixed flowing gas test. This is something interesting. There's a severe corrosion test way where all of these are exposed to very nasty gases. So you can imagine if you have a PC board and expose these to very nasty gases and they withstand those nasty gases, that's a protection what we need. And again, this is just a summary for a few chemicals out there. So what is the value of these protective coatings? I believe by now, talking about it, most of you realize that the value is that we have to protect the board because there are so many problems, so many incidents can happen. And then you can see that this is just a number here, but it's a high number, the average product liability. That means that product liability is a serious concern for unprotected products. With product recalls, the real cost comes later. You can imagine if there is a recall on your product. After the product recall, we believe 50–55% of the customers or businesses would temporarily use a different brand, so they go away from your brand, temporarily use someone else, or almost 15% wouldn't even buy that particular recalled product again. So this can definitely be a damaging thing for the brand itself if there's a recall. And roughly 20–25% wouldn't even buy any brand associated with the same manufacturer because there was a failure. So this could definitely be a real damage to the brand itself and then the product of the company. So we believe that based on that, nano coatings are a perfect solution to help make sure that the manufacturing products work as designed, and ideally well beyond their useful life. Of course, if there's a useful life of the PC board itself, as we discussed earlier, but then the enclosure or the protection can fail earlier than the board itself, that's not good for us. So we have to make sure that we use these nano coatings, and as I said, these are the perfect solution to make sure that the board itself is protected well beyond the useful life of the board. This is getting more and more critical in the environment here. So let's see. So today we talked about a few things here at this webinar. So just to wrap it up real quick, we talked about how we can get rid of the bulkiness, how we can get rid of the extra weight these enclosures can potentially add to the board, to the product itself. And at the same time, we talked about how we can reduce or eliminate the need for these complex customizations. I mentioned earlier that there's no such thing as an off-the-shelf enclosure can protect the component or the board. Not only that, but customizations are important. If you buy an off-the-shelf enclosure, I'm sure that for connectors or for cables or for something you need to cut a hole, have a port, and then these can, of course, add more complexity to protect the board itself if they are not properly sealed. And then again, these seals can also go wrong. So why do we go into all of these extra steps instead of just doing getting the job done the right way, namely protecting the board from the inside out, as I mentioned earlier. And then, of course, we talked about the costs. It's important to understand that costs are getting more and more critical because of all the competitors are out there. There is a race who can get the board or the product cheaper or better. So if we can get something more cost effective, we can get a better product, we can protect the product itself the right way. That definitely can help driving the cost down. And then we need to meet the requirements of the customer. And then these requirements can be met by some proven ways. Of course, the enclosure is a proven way earlier, but I believe after this webinar you can see that potentially, even though we try to protect the board, some moisture or something can get inside, which can work against us. And then at the same time, we need to make sure that we enhance the performance. There's nothing good in that if you have your PC board and then the life cycle of that PC board is, I don't know, 4 or 5 years, but the life cycle of the enclosure is much shorter. That does not do any good for you. So the performance is an important thing. We have to make sure that we enhance the performance of the board itself. So are we ready to design a better product? I believe the answer is yes, otherwise you wouldn't be here today. We need to design a better product. Here at HZO, our mission is to protect the electronics from the most demanding environments by doing it at the same time with a world-class nanocoating to enable a better, more durable product. I believe this sentence summarizes very well our mission and then why we are here. So this is our mission. We've been here for a while. We've been working on conformal coatings for right around 10 years, and we design and build our own equipment. One of the equipment, as an example, can be seen on the bottom right of the screen. This is one of our equipment we use to protect the PC boards. This is a vacuum coating machine, and I believe this is the way to protect the electronics itself, again, from the inside out, instead of having an enclosure there. We have a firm commitment to R&D, and we have several ways of protecting these electronics, several technologies. We call it the spectrum of protection. We can use CVD processes for Parylene. We can use PCVD processes, plasma deposition for any kind of gases. And then, of course, there are some ALD, atomic layer deposition ways. So the bottom line is we have the spectrum of protection. You imagine something, we believe we have the solution for it, depending on your product, depending on your requirements. The history here, again, the last 10 years, we have done a lot. We have a global footprint. We are here. The headquarters is here in North Carolina in the United States, but we have facilities in Europe. We also have multiple manufacturing centers in China and Vietnam. And of course, the future, our goal today, the future is happening. Our goal is to be a one-stop shop for all of these thin films. As I mentioned earlier, spectrum of protection is important. And of course, we want to make sure we help to drive the cost down. So this is an important part of our mission here at HZO. And just to mention some of our results, we believe that the results speak for themselves. HZO has several larger customers. Because of the confidentiality, unfortunately, we cannot really mention most of their names, but there are several customers where we have co-marketing agreements with. Even our logo or name can show up on their products or the product box, or sometimes even in the firmware or in the software of the product itself. Just to mention one, a Samsung electronics company, PrismView. Here we were able to achieve almost 3x or 100x performance improvement versus some other previously applied popping or coatings. We were able to cut almost a quarter of the cost out versus the traditional way they used before. And of course, reduction in the weight itself was an important thing. PrismView, this company, they use LED boards next to the highway. I'm sure you've seen their products or elsewhere as well. You can imagine they are out there in the environment. They have to be protected. 10% reduction in the weight is important. 25% cost reduction is important. And of course, the most important is performance improvements. Well, the other customer of ours is Sarcos, and there we were able to also do some impressive numbers. You can see that big round number down there, 0. So 0 product returns attributed to coating issues. That's an important number. You cannot do better than that. So if you do the coating and then none of those come back, we believe that's a success. And then again, as I mentioned earlier, there are some customers where we cannot mention names because of the confidentiality, but they also confirmed to us that because of our coatings, 0 product returns were done. So I'd like to just conclude here the webinar. We can see the next steps. If you're interested, definitely make sure you check your inbox. We will be sending out materials, some white papers, but during this webinar, you heard why it's important to properly protect these critical electronics. The conclusion is that while enclosures get the job done one way, with the advancements in technology, there are additional or better ways to protect these critical components. So our mission here at H0 remains the same. We have to protect what matters the most to you. This is our mission. This is our product. We've been doing it for a while. We've been doing it for a long time. And we are confident that we can service almost every market segment with our product. So this is what I was excited to share with you today. So I'd like to thank you for your attention. Thank you for your time. And before we conclude today's webinar, I believe we have already received a few questions during this presentation, and I'd be happy to address some of those questions with you now. And also, as I mentioned earlier, we will be sending some white papers outlining these thin film protection ways. And so please check your email you used to register for this webinar. Check your email for more of these materials. And I would also like to ask you to please ask more questions here in the chat box. And if time permits, definitely I will try to address those. So once again, thank you for your attention, and back to you.
Thank you so much, Salt. Great presentation. I really appreciate it. And now on to our Q&A, the portion of our event. As a reminder, to participate, just type your question into the text box that's located to the right of the presentation window, or click on the Q&A icon at the bottom of your screen. If we're not able to answer all submitted questions during today's webinar, we'll be sure to share them with Zolt, who can reply to you offline. So let's get right in. There's a ton of questions in the queue already. So let me start out with a question from Muhammad, who says, what are the design requirements and constraints and limitations in the IC design industry, especially for CMOS?
Excellent question. Of course, different products require different ways of applying these protections. I mentioned earlier that we use a so-called conformal vacuum deposition technique. So here we place these PC boards or these critical components inside of our proprietary coding equipment. So technically we have an application engineering team. Our team can discuss with your team what your products are. We can potentially give you ideas how to modify your product to make it more so-called protectable or make it more durable. So all of these are part of our processes, how we can communicate with current and then future customers. So if you have a specific need, like you mentioned, this IC thing, I recommend you get in touch with our application engineering team. They are definitely well prepared to answer any kind of concerns or questions you have.
Terrific. Keep the questions coming. This one from Robert, who wants to know, what is the process to rework or repair a disturbed coating?
You know, this question comes up all the time, and then I'm glad it came up here, because repair or rework, first of all, our coating is completely reworkable, completely repairable. If your PC board is a very high value board, you want to make sure you don't throw it away if something or a component fails on it. You want to make sure that you can remove that component, put the new component onto the board itself, and then of course provide the protection. So all of our coatings are reworkable, and we definitely, on our R&D roadmap, we definitely have more ways of coming up with reworkability, since this question came in from more and more customers, because you can imagine nowadays things are getting more and more expensive, and they want to make sure that they don't waste those, they don't throw them away. So there are ways to rework it. We can replace a component, we can remove a component, and then depending on what the component was, we have ways to apply to protect that part only, or we can simply push the board through our coating process, and then that can provide the adequate protection.
Okay, great. Thanks for that one. Michael wants to know, what effect does a coating have on thermal dissipation for the PCB?
Right. I mentioned earlier that these coatings are very, very thin layers. Since it's a very thin layer, literally we're talking about microns here. You can imagine that the thickness of your hair is roughly 100 microns, or in this range. We are only talking about 1, 2, 5, 10 microns. So you can imagine it's a very, very, very extremely thin coating. Since it's a very thin coating, heat can easily pass through. This is the beauty of applying some of these conformal coatings, especially Parylene, what we have here at H0, that it's an amazing, excellent layer. And then I'm always joking about this one, that it's so lightweight, it's so transparent, it's so, you cannot touch it, you cannot see it, you cannot feel it, but it's there and it gets the job done. It's a very, very thin layer. Because of the thickness of the layer is very thin, heat can easily go through, and heat dissipation is very simple.
Okay, terrific. Keep your questions coming. We will get to as many of them as we can. And the ones that we don't have time for, we'll get a written response from Zolt afterward. David asks, do you have some pictures of what devices look like with once they've been enclosed in this manner?
I believe one of the slides included a picture, but on the right side there was a board which had corrosion on it. Of course, that did not have our coating, and on the other picture we saw the board. To be honest with you, again, as I mentioned earlier, as I joke with this, the protection layer is so thin, it's so transparent. It's like 90–95% transparent. So you cannot see it that it's there. You cannot feel it that it's there. You cannot smell it that it's there, but it's there. So technically, if you really look at a board with the protection layer, what we apply onto it, you barely notice any differences. Of course, depending on the technology itself, I mentioned Parylene or mentioned the CVD process, chemical vapor deposition process. This is a very highly transparent layer, so you cannot really see it. I believe you have to use a magnifier glass, so you have to go very, very close to the board to see the difference. Of course, if you use a different technology like PCVD, you might see some minor discoloration of the board itself, but I would say I've been doing this for a while, and I myself have a hard time differentiating between the coated and then the uncoated board. Of course, there are ways and there are test methods you can apply to see the thickness of the coating, the transparency of the coating, even the weight of the coating itself. So there are ways to do that, but with your eyes, I would say barely noticeable.
Thank you for that. Orges asks, how do you apply a coating to ensure full coverage of all surfaces, like under chips and in other hidden areas in a PCB?
Without being impartial, I believe this is my favorite question, and I can talk about. I believe we can have another webinar just to cover this topic. But the short answer to this question is it's a conformal coating. Conformal coating means it goes literally everywhere. You can imagine it this way, that if you spray coat something, the spray coating is a line of sight process. Line of sight process means, let's say you have a keychain. You put that keychain down on the table and you use a spray can, and then you start spraying on top of it, and then you remove, you remove the keychain. There is no coating under it, right? Because it's a line of sight process. Our coating is a completely conformal coating. It happens inside of our proprietary CVD or PCVD or ALD process chambers. All of these are happening under vacuum. So we make sure that we pump the atmosphere out of this vacuum chamber. And once again, this is a fully automated process, so don't be scared about the complexity of this. But we pump the air out of the system, and then we start filling it up with our, I would say, proprietary the mix or the chemicals coming into the chamber. And then since this is a CVD, chemical vapor deposition process, it's a highly conformal process. So literally these molecules go everywhere. Since we are in vacuum, they fill up the space, and they go under the chip. They go even inside these little cracks. If there is a crack on the chip, they go under, inside, on the side. Literally layer by layer, they build up the film itself, providing a fully conformal coating.
Thank you very much. Orges has another question, which is, how much does this coating technology cost compared to other coating technologies?
That's the other favorite question of mine, and then I get asked the same question over and over again. And my answer is, please don't expect a specific number, because there is no such thing. Depending on the complexity, depending on the size of the board, depending on the technology or the material we use to protect it, it can be anywhere between, I would say, a few cents to a few dollars per board. But again, I cannot really give an answer with a specific number, because it depends on a lot of things, as I mentioned earlier. But what I can tell you for sure is definitely it's a much cheaper per unit cost than trying to enclose it with something, or trying to use gaskets, or trying to use silicone coatings. It's proven, because again, we've been in this industry or in this business for almost a decade now at H0, and one of our core strengths is to provide a very cost-effective solution.
Okay, thank you. And finally, a third question from Orges is, can you use this coating for power components like inductors or transformers on a PCB, or on a non-PCB mounted power component?
I would say this question is best asked from our application engineering team, but based on my experience here, the answer is yes, because I know that we used it on several different industries: consumer electronics, automotive, medical industry, aerospace, IoT, or even industrial applications. So the answer is yes, you can use them. Of course, we need to make sure we carefully select the material itself and then the technology itself. I give you an example. If there is a sensitive chip on the board, which is very, very sensitive against radio frequency, we cannot use a PCVD way, the plasma enhanced chemical vapor deposition. We have to use something else because we want to make sure we don't interfere with the component itself on the board. So I would say part of our spectrum of protection, you come to us with the problem itself, go to our application engineering team, and I'm confident that they will be able to provide the right technology and then the right answer to this question.
Thanks very much for that. Question from Darren is, how do the coatings affect RF characteristics, specifically in 2.4 and 5 gigahertz bands, and how do you accommodate for external connectors?
Let me answer the second part of the question first because that's the easier. I believe that came up with many times that, we know that our coating itself is a non-conductive layer, right? If it's not conductive, how can we use connectors, external or internal connectors? There are ways to do that. So during our manufacturing process, we can either apply a mask and then do the coating and then remove the mask. Of course, it can be fully automated. Or we can use the technology where we can apply a very, very thin layer, and then when you do the connection itself actually breaks the coating itself off where it's needed, so the electrical connection can be made. So the connectors are not the problem. The first part of the question is a little bit trickier because depending on, of course, what frequency the RF needs to go through, again, my answer is select the correct material. And then you don't have to do the work. You don't have to do the legwork. Let us do the legwork. Come to us with the specific problem, and then the application engineers will recommend, let's use this material, this gas, this way, this method, this technology, and then based on that, you already told us your requirement. The requirement is 2 gigahertz or 5 gigahertz RF power or RF frequencies should go through it. We recommend the solution.
Okay, thanks for that. Here's a question from Dimitri, who first of all thanks you for the presentation and says if the product needs to meet requirements for minimum distance between component pins, which cannot be met with increasing the component size, can he use the nano coating to use smaller components for such a requirement?
My answer is in one word, absolutely. Not only absolutely, but this is another advantage of using these nano coatings. As I mentioned earlier, the thickness of your hair is 100 microns, right, or in that range. Mm-hmm. We are roughly 10% or even less than that with our coating. So the distance between components on a board is an important consideration because everything is getting smaller and smaller and smaller. These devices are getting smaller. Because the devices are smaller, the distances are smaller between components. So if you apply a very thick coating on it, or you dip coat it with silicone, or you try to protect it with a rubber gasket, now you work against yourself. Use a nano coating. The nano coating, the name says nano coating. It's a nanotechnology. It's so thin, especially if you use our ALD solutions in certain cases. The ALD can be in the nanometer range, which is even 1/10 or 1/100 of the micron, right? So we can go down to very, very, very thin layers where component distances are not affected at all.
Terrific. Thanks for that. Keep the questions coming. We'll try to get to them all before our hour ends. Ones we don't have time for, we'll get a response afterward. This is from Thomas, who wants to know, are the coatings hydrophobic, and what type of chemistry can they be composed of?
We have hydrophobic coatings as well. Now, I give you a better answer to this one because let's assume that hydrophobicity is one of your requirements. Just to explain to everybody, that means that we want to make sure that, for example, splash resistant or oleophobic, that's another different a different type of coating requested from some of our customers. Namely, we want to keep the oil or the fingerprints of the board. So that hydrophobicity is an important thing because even though we want to make sure that the water or the chemicals or the salt fog or any of these environmental hazards do not alter the product itself, applying a hydrophobic coating on top of it can actually help to further keep away the moisture or keep away the water from the surfaces. So you can imagine it as a repellent. Your car windshield, when it rains, there are some ways you can apply a coating on that windshield, and then that helps to get rid of rain. That's very, very similar to the hydrophobic requirement here with the board. So definitely we have chemicals, we have protections, we have thin films if your requirement is hydrophobicity.
Terrific. Thanks again for that. Dimitri wants to know, what's the final thickness of a coated material on a PCB?
Our experience tells us that it can be anywhere between 1 to, let's say, 30 microns. We believe that even a 30 micron range is not necessary, but some of our customers require a thicker coating, but you can imagine, once again, the thickness of your hair. Keep that in mind. That's in the range of, 80 or 100 microns. We're talking about 20, 30 microns here. That's what we, based on the last decade of coating components or coating boards, probably that was the thickest we have ever gone. Of course, we have capabilities of going much thicker than that, 50, 100, 500 microns, but we believe it's not necessary. Now, of course, it can also depend on the requirements from the customer. If they require this coating to withstand certain chemicals or certain environments, based on that, our application engineering team will recommend the coating thickness itself. And as I mentioned earlier, potentially we can make some recommendations how to change the board. Changing the board meaning we are the experts of coating these or protecting these devices. We can give you an input of move these components from here to here or somewhere else to make it easier, to make it more durable. So based on that, we provide this protection level.
Thanks. This question from Glenn, who wants to know, can Parylene coatings be removed for rework if needed?
As I said earlier, that's one of my favorite topics, and then the answer is yes, Parylene can be removed. Now, I know this can be a little bit confusing answer because Parylene is so-called not the easiest to remove, but there are solvents out there we are able to so-called rework or remove the Parylene. Here at Aidsville, we have several different types of Parylene coatings available. Just to mention a few: Parylene C, Parylene N, Parylene F, and then some other Parylene E or some other proprietary blends. And some of these, depending on the requirements from the customer, is exactly reworkability. So based on the reworkability requirements, we recommend a certain type of Parylene to be used. And then based on that Parylene, we can also show the way how it can be removed or dissolved or completely eliminated from a specific part of the board itself. And we have processes and we have ways to do that.
Just have time for a couple of more questions. Dan wants to know, when a piece, and a number of questions have come in about this, when a PCB is coated, how are you able to deal with connectors between multiple boards without creating a failure point?
Right. Sometimes these connectors can be a failure point because keep in mind, it's exactly against what we try to do, right? We try to protect the board with a non-conductive layer. Of course, connectors, non-conductive layer cannot work, so we have to make sure that somehow either do masking and then do not coat that connector, or we can just provide a very thin layer of coating. So when the connectors are pushed together, it's a connect-through kind of coating. So namely, the electrical current or the signal can go through. Now, of course, yes, here it's a problem. It can be a failure point because of the masking. Potentially there are some issues with the masking, or potentially there are some issues with the connective coating. So we can recommend a few ways to do so, maybe a secondary sealant in this area, in the specific area. But you can imagine if you have a large board and you only have a few connectors to protect, then the cost is still much less than trying to do it with some other technologies, because now you don't need to protect 100% of your board. You only need to potentially 10, 20, 25% where the connectors are present. So the answer is yes, there are ways to do so, and we are prepared to answer this because this question, as you said, came up multiple times. It came up to us multiple times as well.
I understand. And with that, we are out of time. That's all we have for questions today. I want to thank you, Zsolt Pulai. Design News appreciates your time and expertise on today's topic. And thank you to our sponsor, HZO, as well to everyone in the audience. We appreciate your attention and your participation in the polls and all the questions. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. That way you can invite colleagues and peers who may not have been available to listen live to the event. This webinar is copyright 2021 by Informa. The presentation materials are owned by or copyrighted by Design News and HZO. The individual speaker is solely responsible for his content and his opinions. On behalf of our guest, Noel Pillai, I'm Michael Krieger. Thanks for your time and have a great day.